So we worked 1 through 10 on Monday. So we're going to finish the review. So remember, you'll have your review and your test are due this Sunday. And don't forget to send me your scratch. All right, number 11. So the first several problems that we're going to go through are going to give us two functions, an f of x and a g of x, and then tell us what it wants to do with those two functions. On number 11, the functions are f of x equals negative 11x plus 13. And g of x equals x squared plus 2. So it gives me those two functions, and it wants me to find f of 10 over g of 10. So what this says is to go to your f function and replace its x with a 10. Then go to your g function and replace its x with a 10. You're going to get two solutions. You're going to put your f solution over your g solution. So let's find the two solutions first. So f of 10. Go to f and replace your x with a 10. So I'll have negative 11 times 10 plus 13. Negative 11 times 10 is negative 110. Bring down the plus 13, and negative 110 plus 13 is negative 97. So now let's find g of 10. So this means to go to my g function here and replace its x with a 10. So I'll have 10 squared plus 2. 10 squared gives me 100. Bring down my plus 2 to get 102. So what does it want me to do with those two solutions? Whatever I got for f is going to go over what I got for g, which will be negative 97 over 102. Now you would check to see if that does reduce. And remember how to do that. Just put that in your calculator, negative 97 over 102. Hit enter, get your decimal, and then hit your math, enter, enter. And it just so happens to still give me negative 97 over 102. If it was going to reduce, it would have reduced it right there. But it just, that is already in simplest form. All right, number 12. Same start. It's going to give me an f function and a g function. And it asks me to do something with them. My f function is negative 5x plus 4. My g function is x squared minus 2. This time it wants me to find g minus f of x. So what I'm going to do here is find g of x. Then I'm going to find f of x. And then I'm going to subtract them. So let's see, what is g of x? Well, this actually means go to your g function and replace the x with an x, which means don't change anything at all. So I'm still going to have x squared minus 2. Then it's going to ask me to find f of x. So the same thing happens here, right? If I go to my f function and replace this x with an x, I haven't done anything at all. So it's still negative 5x plus 4. Now, what does it want me to do with these two solutions? It wants me to subtract them. Subtract the g solution, which is x squared minus 2, minus the f solution, so minus negative 5x plus 4. Now, you'll notice I put parentheses around this second part, because if I'm subtracting the whole solution, I have to put parentheses around that whole solution. If not, I'm just would be subtracting the negative 5x. I don't want to subtract that. I want to subtract the negative 5x plus 4. So that's why the parentheses are necessary, because look what happens. If you distribute that, that's going to change those signs. So I'll still have x squared minus 2. This minus turns that into a positive 5x, and this minus turns this positive 4 into a negative 4. Now I just need to clean this up a little bit because I have like terms. I can put that negative 2 and that negative 4 together since they are like terms. So now I'm left with the x squared. After your squares comes your x's, so plus 5x. And then, like I said, put those like terms together. That negative 2 and negative 4 put together gives you negative 6. So minus 6 at the end. Number 13, f of x equals x squared minus 20. G of x equals 19 minus x. And it wants me to find f minus g of negative 10. So the first thing I'm going to do is I'm going to find f of negative 10. Then I'm going to find g of negative 10. So I'm going to do those two things, f of negative 10 and g of negative 10. And then I'm going to subtract, right? That's what it's telling me to do to my solutions. I'm going to subtract the solutions. So let's see, f of negative 10, I'll go to my f function and replace that x with negative 10. So I'm negative 10 squared minus 20. Be careful squaring things in your calculator. If it's negative and you're squaring it, it's going to have parentheses around it. Negative 10 squared gives me 100. Bring down the minus 20 to get 80. So there's your first part. Now find g of negative 10. I'm going to put my negative 10 in this spot now. Be careful with your signs here. I've got 19. Then this minus. Now after I put the minus, I'm going to replace this x with negative 10. So what does this actually mean I'm doing here? If you're subtracting a negative, you're really adding. So I really have 19 plus 10, which gives me 29. Now remember, what does it want me to do with my solutions? That says to subtract them. So I'm going to have 80 minus 29, which gives me 51. All right, number 14. Gives you a 3-part question. But the good part is, once you figure out the first part, that's the answer for the other 2 parts also. It gives me 2 functions. F of x equals 1 over x minus 8. G of x equals 9x cubed. And it wants me to find the domain of 3 different things. It wants me to find the domain of the sum of these 2 functions. It wants me to find the domain of the difference of those 2 functions. And it wants me to find the domain of the product of those 2 functions. So the sum of these functions means if we're going to add those 2 functions together, what would the domain of these solutions be? Well, if I'm adding these 2 functions together, that would mean I would have to get a least common denominator and all this mess. The hardest part to do of that would be to add those 2 things together. But the thing is, it doesn't matter if you start off with this denominator, that's going to be the denominator of your answer. Now remember, when we are finding the domain, our goal is to find what can x be. So you're looking for restrictions on the domain, which means what do I need to leave out? What can x not be? So when I'm looking at these 2 functions, I've got 1 over x minus 8 and 9x to the 3rd. Anytime you see a fraction with an x in its denominator, that's going to give you a restriction on your domain. And the reason is the denominator of a fraction cannot be 0. That is undefined. So I need to find out what makes this denominator be 0 because I need to leave it out of my domain. So x minus 8 cannot equal 0. Solve it for x, which just means to add the 8 to both sides. Cancel out that minus 8, so x cannot equal 8. So there's the restriction on this function. Does this function have any restrictions? In other words, is there a denominator with an x in it? No, there's not even a denominator at all. So that one doesn't have any restrictions. So the only restriction on the domain of all 3 parts of this problem is x cannot equal 8. Okay? So when all of these are going to have an A or a B option. The B option is always going to say x is a real number. The A option will say x is a real number and then it's going to give you a blank. That blank is where you put in your restriction. You would say, and x cannot equal 8. On all of those. 15. It's going to give me two functions again. F of x is 3x minus 7. G of x is 7x minus 42. And it wants me to find the domain of f over g. So we're just going to write our f function over our g function and see what that looks like. F is 3x minus 7 over g, which is 7x minus 42. So there's what f over g looks like. Now, what is the domain? Which means, is there any restrictions? I don't care anything at all about the top. Just ignore it. What I'm concerned about is this x in the denominator. I don't want what I plug in for that x to turn the denominator into 0. So once again, just set your denominator to not equal 0 and solve it. And that's going to be your restriction. So if I solve this, I'll have to get rid of the minus 42 and the plus 42. So 7x cannot equal 42. And then divide by 7. So x cannot equal 42 over 7, which is 6. So x is a real number, and x cannot equal 6. All right, going into number 16. This is when we moved into section 9.1 and we did the composition of two functions. So we've added, we've subtracted. Now we're going to find the composition of two functions. So on 16, f of x equals 4x plus 3. G of x equals x to the third. And this time it wants me to find f of g of negative 4. When you're finding the composition of two functions, you always start with the inside. So I'm finding this part first. So g of negative 4. Once I get that solution, I'm going to find f of whatever that solution is. So find the inside first. So I'm going to my g function and replacing its x with negative 4, which will give me negative 4 to the third power. Negative 4 to the third power is negative 64. So there's that solution. That's what tells you to find f of. So I'm finding f of whatever that answer was. So since it's negative 64, that's telling me what to go to my f function and replace the x with. So if I do that, I'll have 4 times negative 64 plus 3. So let's see, 4 times negative 64 gives me negative 256. Bring down the plus 3, and negative 256 plus 3 is negative 253. All right, again, it's going to give me two functions. Ask for the compositions, and then ask for the domain of the answers. So let's see what I have here. My f of x function is 9 over 1 minus 5x. My g function is 1 over x. So what it's going to want me to do is find, in the first place, f of g of x and then its domain. All right, I'm going to take my mask off since there's no way in here. F of g of x and its domain. And then it's going to ask me to do it the other way around, which would mean in a minute I'm going to do g of f of x and its domain. So let's see what I start off with. I'm finding g of x. Well, g of x is just 1 over x. Now, I'm going to pause because now remember, if I'm finding a composition, the next thing I've got to find is f of that solution. But before I go there, when I'm going to find the domain here in a minute, I have to look in two different spots for restrictions. The first spot I have to look at for restrictions is right here. Okay, so when I'm finding the domain, I'm just going to write this over here to remind myself that I do have a restriction here because I have an x in the denominator. So if the denominator can't equal 0, that means x cannot equal 0, right? Because this right here can't equal 0. So I'm going to just keep that in mind for in a minute when I'm doing my domain part. So now, I've found g of x. The second part now means I'm going to find f of that solution. What is that solution? It is 1 over x. This is where it gets messy. So let's see, if I'm finding f of 1 over x, that means I'm going to go to my f function and replace this x with 1 over x. So let's see what that looks like. I'll have 9 over 1 minus 5, and instead of x, I'm going to write 1 over x. Now, here's the thing. I need to clean this mess up. I can't leave my fraction with a fraction in the denominator. So what you're looking at to fix this is whatever this denominator right here is. That tells you how to fix it. That tells you what you're going to multiply the top and the bottom by, whatever this is. Because look what's going to happen when I get to the bottom in a minute. This x will cancel that one, which is what you want to happen. So up top, 9 times x gives me 9x. Now, in the bottom, this x does go to both parts of that. So what's my first part? X times 1 just gives me x minus. Now, here's why we used it, because when I get to multiplying x times this part right here, that x cancels that one, so I'm just left with minus 5 times 1, which is just 5. So there's your answer to f of g of x, 9x over x minus 5. Now, to the domain part, remember, you're looking in these two parts for restrictions. I've already noted that restriction because that x can't equal 0. Well, neither can x minus 5, right? It's a denominator with an x in the bottom. So x minus 5 also can't equal 0. If I solve this one for x by adding the 5 to both sides, I find out that x also can't equal 5. So when I'm doing the domain part of this, x can't equal 0, and x also cannot equal 5. Now, here's the other tricky part is it doesn't just say x is a real number and x can't equal 0 or 5. It wants you to write it in what's called interval notation, which means all the numbers on the number line from negative infinity to positive infinity except 0 and 5. So what is included? That means all the numbers below 0, all the numbers between 0 and 5, and then all the numbers above 5. So here's how you would write that. How do you write all the numbers below 0? That's going to look like this. Negative infinity to 0. That includes all the numbers below 0. And it's going to have a little u. And this is a multiple choice part, so it'll have all this written out for you. That means and. So what do you want to include after all the numbers below 0? In your second grouping, you'll want to include all the numbers between 0 and 5. And the last group is all the numbers above 5, which would be 5 to infinity. So it'll be those 3 things as your domain. All right, so that's just the first half of this problem, right? Because what I have done is I have found f of g of x, which gave me 9x over x minus 5, and then the domain. And when I would do the domain, I had to look in 2 spots for restrictions, these 2 spots right here. And I found that x couldn't equal 0 and x can't equal 5, and then I wrote it out in interval notation. So now I'm going to find it the other way around, which means switch that g and f. So I'm going to find g of f of x and all that. So let's see. So this time, the inside is f of x. So that's what I'm finding first. So f of x is what? 9 over 1 minus 5x. That is the first spot that you're going to look for restrictions in your domain. So you kind of just pause there before you find the g part of your problem. So let's look. What can x not equal right here? Well, this denominator, which is 1 minus 5x, can't equal 0. So let's figure out what makes that happen. I need to subtract 1 from both sides. So negative 5x cannot equal negative 1. Divide by negative 5. So now x cannot equal, this negative over a negative turns into positive 1/5. So let's write that over here in my little side note of my domain. What's the first thing x cannot equal? It can't equal 1/5. So let's just remember that later on in the problem when I'm trying to find the domain. So let's see, I have found f of x, which is 9 over 1 minus 5x, which tells me now I'm finding g of this solution, which is 9 over 1 minus 5x. So what does that mean I'm supposed to do? That supposed to go to my g function, and wherever I see an x, I'm supposed to put in 9 over 1 minus 5x. So let's look at what that looks like. Go into g. I have 1 over. What do I put in place of x? All this, so 9 over 1 minus 5x. So once again, I just need to clean this up to get my answer. Just like the last problem, the last part of this problem, the denominator had a fraction in it that had an x in the bottom. So I'm going to clean this up by, remember how you do that, is whatever the denominator of your bottom of your fraction is, that's what's you're going to multiply the top and the bottom by. So this whole thing, 1 minus 5x, 1 minus 5x, because look what's going to happen in the bottom. What's this 1 minus 5x going to do? It's going to cancel that one. So that's why you're using it. So let's see what it gives me up top. This 1 goes to both of those. The good thing about 1 is that when you multiply it times something, it doesn't change anything. So 1 times all of this is still 1 minus 5x. And look what happens very nicely in the bottom. The 1 minus 5x's cancel each other out. All you're left with is 9. So there is the answer to g of f of x. So back to the domain part of the question. I already found the restriction in my first part. Now I need to look at my final solution and see if there's any restrictions here, which would mean, are there any x's in the denominator of my answer? There's not, right? There would be an x somewhere down here, and there's not, which means this part doesn't have any restrictions. So the only thing I need to leave out of my domain is 1/5. So if I'm writing that in interval notation, that means everything from negative infinity to positive infinity except 1/5. So everything below 1/5 would be negative infinity to 1/5, and everything above 1/5, which would be 1/5 to infinity for your domain. All right, number 18 talks about determining whether a function is one-to-one by using the horizontal line test. What the horizontal line test says is if you can draw a horizontal line, which is the one that goes straight left to right, and only touch the graph once, then your function is a one-to-one function, and it'll have an inverse. So let's look at what the graph on number 18 looks like and see if it's one-to-one. So here's your x and y axis. Here's your x, there's your y. The graph on number 18 looks like this. And it wants to know if it's a one-to-one function. So let's see, what does that mean? If I draw a horizontal line right here, how many times did it touch that part of the function? It touched it twice, which means automatically right there, that tells me it's not one-to-one. I could have drawn it even up here. I would have still touched it twice. So there's several different places on here to where you would touch the graph twice with a horizontal line, which means not one, two, one. Now, on number 19, gives me a function and it says, is it 1 to 1? And then if the answer is yes, find its inverse, because only 1 to 1 functions have inverses. So let's look. F of x equals 3 over x plus 4. So if you wanted to check that to see if it's 1 to 1, you can put that in your y equals 3 divided by, then I'm going to put that denominator in parentheses to show that that whole thing is the denominator. X plus 4. X plus 4, close. Then I'm going to graph it. So there's what that would look like on the graph. So if I draw a horizontal line anywhere, there's nowhere I would touch it more than once. So it passes the horizontal line test, which is why, yes, that is 1 to 1. So the first part of that is, yes, it's 1 to 1. Now, since it is 1 to 1, it wants you to find the inverse. So what finding the inverse of a function means, I need to switch where my x and my y are. Well, if I'm looking at this right now, I don't even see a y. But remember, what is f of x? That's your y, isn't it? F of x and y mean the same thing. So this really says y equals 3 over x plus 4. Now I can interchange x and y. So just flip-flop those. So it's going to have x equals 3 over y plus 4. Now, the last part of finding the inverse is now your y has switched spots, but it always likes the y to be by itself so that I can graph it if I wanted to. You're not going to have to, but if you wanted to graph it, you want y to be by itself. Well, since the y is in the denominator, the first thing you're going to do is fix that, which means multiply both sides by this denominator. So I'm multiplying both sides by that y plus 4. Oh, whoops. Because look what happens on the right. That y plus 4 on the top cancels the y plus 4 at the bottom, and the only thing I have over there is 3. On the right, I'm going to distribute that x to both of those. So x times y gives me xy plus x times 4 gives me 4x. So when you multiply both sides by that y plus 4, it puts your y up level, so that up in the top, so that now you can isolate it. The first thing I want to do to get y by itself is to get rid of plus 4x with minus 4x. So now I still have xy over here. Equals, those terms are not like terms, so I can't put them together. So I'll just put them as two separate terms over there. So 3 minus 4x. And to solve for y, I need to get rid of that x. So since it's x times, I'll get rid of it by dividing everybody by x. So my x is canceled. There's my y equals 3 over x doesn't simplify, so I just have 3 over x. Minus, look what you have here though. Those x's do cancel. So when they cancel, all you're left with is the 4. So 3 over x minus 4. Now, the next 3 problems are all systems of equations problems. This is that 3.5. And we shortened our workload here because now we know how to work these problems with our matrix function on our calculator. So let's work them with that. Number 20. You have 4x plus 3y equals 40. And 3x plus 4y equals 44. Now remember how we turn these into matrices. I'm going to create matrix A from the front part. Matrix B will come from the part that's after the equal signs. Now we're just using the coefficient, just the numbers, not the x's and the y's. So what's going to be the first row of matrix A? It's going to be 4, 3. The second row will be 3, 4. Matrix B is this column right here. So 40 and 44. Now, when we get into our matrix function here in just a second, the first thing we're going to have to tell it is the order of each of these. The order is how many rows, which is 2, by how many columns, which this one is also 2. What is the order of this one? It has, again, 2 rows. By this one only has 1 column. So 2 by 1. So let's go to our calculator. Now remember, to get to matrix, you'll hit second, and then the next to the -1 button will get you to matrix. So we are in the edit mode right now, right? Because we need to create those 2 matrices. So go over to the right to edit, and you want to edit matrix A. So go ahead and hit enter. Now, your matrix A probably still says 3 by 3 because that's the last ones that we were working with. So we want to make sure that we turn it into a 2 by 2. So 2, enter, 2, enter. So if you'll notice, that makes your matrix just have 2 rows and 2 columns. You're just now going to enter the first row, which is 4, 3. So 4, enter, 3, enter. And then the second row. So 3, enter, 4, enter. So just make sure your matrix A matches that matrix A on the board. So 4, 3, 3, 4. Now go back to second matrix. Still editing. Now we need to put in our B matrix. So make sure you go down to B. So go down 1 and hit enter. It probably says 3 by 1 still from your last problem. So make sure you turn it to 2, enter, 1, enter. Make it 2 by 1. And then enter the 40 and the 44. So 40, enter, 44, enter. Oops. Now what you're going to want to tell your calculator to do is matrix A to the -1, matrix B. So go back to, well, first of all, just quit. Get all the way out. So you'll hit second, and then right next to it, quit. Now go to second matrix. I'm not editing anymore. I already did that. So just hit enter. So that should put matrix A on your home screen there. Now hit the X to the -1 button. Now, second matrix, you want to put B, so make sure you go down to the B and hit enter. So A to the -1, B, hit enter again, and there's your X, Y answer. Your X is 4, your Y is 8. So make sure when you enter it, you'll notice it says, even in the instructions of it, it'll say enter your answer as an ordered pair, which means you're going to have to write the open parentheses or a close parentheses. So make sure you enter it as an ordered pair. All right, 21 is the same kind of problem. It's just going to be a bigger matrix. Your calculator will do as big a matrix as you want to do. It can do a 10 by 10 matrix. So this one, 6x minus y plus z. equals -8. 2x plus 2y minus 3z equals -31. And then x minus 3y plus 2z equals 22. So make sure that you wrote it down right first. 6, 1, 1. And then create your matrix A. From that first part, your matrix B from the right side of the equal sign, and then put it in your calculator. We're going to go over a couple of minutes to get through all this. So 6 in front of your y is a -1. In front of your z is a +1. Then 2, 2, -3, and 1, -3, 2 for matrix A. And then matrix B is this column. So -8, -31, and 22. So go back to matrix. Second matrix. Now remember, you're creating a whole new problem. So that's when you go over to edit. You want to edit matrix A, so hit enter. So now, what is our order? What is this one? 3 rows and 3 columns. So you want to make sure you tell it 3 by 3 for matrix A. Then matrix B will be 3 by 1. So the first thing I have to do is change that 2 by 2 up top to a 3 by 3. Oops. To make your matrix stretch out. So then enter the information. So 6, enter, -1, enter, 1, enter for the first row. 2, 2, -3 for the second row. And 1, -3, 2 for the third row. All right, go back to second matrix. Now you want to edit your matrix B. So go over to edit, enter. Ooh, I forgot to go down to B. So second matrix, over to edit. I'm doing the B now, so make sure you go down. Down to B, enter, and turn it into a 3 by 1. So 3, enter, 1, enter. And enter your matrix B. So -8, -31, and 22. Once you create the matrix B, you'll get out. So second, quit. So now you want to do the matrix A to the -1, matrix B. So second matrix A, so it's already there. Hit your X to the -1 button. And then second matrix, make sure you go down to get to matrix B and hit enter and hit enter again. So there's your X, Y, and Z. -3, -5, +5. All right, 22 is the egg cupcake pizza problem. Talking about eating all those things and how much cholesterol from different combinations. So let's just name, it says egg is first, so we'll name egg X. Cupcake is next, so we'll name it Y. And pizza is last, so we'll name it Z. So it says by eating 1 egg, 1 cupcake, and 1 slice of pizza. So it's 1 of each of these. So 1x plus 1y plus 1z. If you ate all of that, you would have consumed 302 milligrams of cholesterol. The second sentence says if you eat 3 cupcakes, which would be 3 Y's, and 4 slices of pizza, which would be 4 of the Z's, you would consume 92 milligrams of cholesterol. And the last sentence says if you ate 2 eggs, which would be 2 of the X's, 1 cupcake, so 1 of the Y's, no pizza, you would eat 568 milligrams of cholesterol. How much cholesterol is in each item? So again, I can create the matrices. From these. Be careful with the empty spots. Those are going to be zeros. So my first row will be 1, 1, 1. My second row will be 0, 3, 4. My my third row will be 2, 1, and then an empty 0. My answer matrix will be 302, 92, and 568. So let's see what each item's cholesterol would be from eating different combinations. So let's see. Back to second matrix. I'm on a new problem, so don't forget, go over to edit. It's still 3 by 3 this time. Enter your 3 by 3 matrix. So 1, 1, 1, 0, 3, 4, 2, 1, 0. So again, you're just making your first matrix match the first matrix on the board. The second one, I need to edit and put in matrix B. So second matrix, over to edit, and make sure you go down to the B and hit enter. Enter your B matrix, which is 302. Oops. First of all, tell it 3 by 1, which it probably already was. You just needed to hit enter, enter. 302, 92, and 568. So there's your answer matrix. Now quit. So second quit to get out. Now is when you're going to want to do your matrix A to the -1, matrix B. So second matrix A, so enter, hit your X to the -1 button, and then second matrix, make sure you go down to get to B, enter, and enter. So there is how much cholesterol each item has. The egg, which is first, has 274. The cupcake has 20, and the pizza has 8. All right, the last 3 problems are graphing the inequalities. So 23 is going to give us an inequality. It says 4x minus 5y is less than or equal to -15. So I want to graph this line, and then I'm going to shade either above or below it, depending on what the inequality ends up being. So if I'm going to graph this, I want to get this y by itself. So I'll do that first, which means I need to get rid of the 4x. So I'll subtract the 4x from both sides. So now I've got -5y is less than or equal to, these are not like terms, so I'll just bring those down. So -4x minus 15. Now, the next step is you have to divide by -5. Everything on both sides to get that y by itself. When you divide by negative, remember, this inequality symbol will flip around. So now I've got y, this turns around to greater than or equal to, which is going to affect where you shade. Negative over a negative turns to positive 4/5 x. That negative over a negative turns into positive 3. So remember, you can go to your y equals and type in that 4/5 x plus 3. Because if I'm going to graph this, I need to get 2 points. So if I graph it, remember, it's going to be a line. If I want 2 points, you can hit second and then your table button. Stay away from all those points that have decimals. So I'm going to graph this one that it's on will be good. -5, -1. I'll plot that. And then I'll come down here and I'll plot that 0, 3. So I'm going to plot those 2 points. So those 2 points, my first point, because remember you have to plot 2 points for MathLab to connect. -5, -1 will be to the left 5, down 1, 0, 3. So left and right 0, up 3. Now remember, you're going to want to either connect it with a solid line or a dashed line, and this is what tells you that. If it has that equal to bar, that means you're going to connect it with a solid line, which is what MathLab will do anyway. If you needed to make it dashed, you'd have to go over in your toolbox and switch it to dashed. So let's look. Y, where are the y values greater than, which means above this line? So use your paint can to shade above the line. All right, last 2, and I know I'm way over. Number 24 is x is less than 1. Now, the good thing about this one is there's nothing really to solve. I can go ahead and graph this. I can't take it to my y equals like I could that last one because there is no y involved. It's just an x. So what that means is it doesn't care what the y coordinate is. You just need to plot 2 points where the x coordinate is 1. So you could do 1, 2, and 1, and -3. Doesn't matter what the y coordinate is. The x coordinate just has to be 1, which means over to the right 1 and up 2 for that point. Again, over to the right 1 and down 3 for that point. So you'll notice it's going to make a vertical line. But remember, you're going to need, so once you graph this second point, it's automatically going to connect it with a solid line, but you're going to need to tell it to dash it, which means just go over into the toolbox box on the right and switch it to dash to make it a dashed line since it doesn't have the equal to bar. Now, since it's a vertical line, there's not an above or below. It's vertical, which means this says, where are my x values less than 1? Well, let's see. All the x's to the left of that line would be less than 1. Last problem. It's going to give me 2 inequalities that I'll graph separately and do their shading. And then pick the multiple choice option of where their shading overlaps each other. So the first one is y is greater than or equal to x plus 4. The second one is y is less than or equal to 3 minus x. So I'm going to graph those separately on this graph. So let's see, x plus 4. If I go to y equals and clear it, I'm graphing this one. So x plus 4 will look like that. So go to your table. So second table, pick 2 points. Doesn't matter any of those points. I'll just graph those top 2. So -5, -1, and -4, 0. So -5, -1 would mean to go to the left 5 and down 1. -4, 0 means to go to the left 4 and then up and down 0. So it'll have a solid line since it's got the equal to bar. Now this one wants to know where is y greater than this line. So you would shade above it. So there's the first line with its shading. Go back to y equals and clear it and put in this line. So 3 minus x and graph it. Second table, get you some points. I don't want that 8. Let's do this one and the one below it. So -1, 4, and 0, 3. So I'm going to plot those 2 points. -1, 4 means to go to the left 1 and then up 1, 2, 3, 4. 0, 3. My x is 0, so I won't go left or right at all. My y is 3, so I'll go up 3. And again, it's a solid line because of the equal to bar. Now, there's that line. It wants to know where is y below that line, less than this line, which is all of this. So if you'll notice, the part where they are both shaded is this part right here, in between the lines that are right here. So that is the multiple choice that you would choose, the one that has that part shaded. There it is. So here's the lines. So shaded in between where that is. And it'll be a multiple choice. So if you're looking at your multiple choice, the part that is shaded in that area would be that one right there. Okay? All right, I know I went way over. So I will see y'all on Friday. So your test, your review and your test are both due on Sunday at midnight. You can do the review as many times as you want. I would suggest doing it several times until you're comfortable with the information and then taking your test, because your test you can only do once. So on Friday, we will do 7-1 and 7-2.